Hello, we are discussing about GATE 2005 ECE paper. For the circuit shown, find the instantaneous current I1 of t, which is a current flowing through 3 ohms. We are going to calculate this I1 of t in the circuit. If you see the circuit consisting of two sources, one is 5 ampere source, the other is 10 ampere source. So the circuit consisting of more than one source, you can use either superposition theorem or it can also be calculated by using simple KCL. You will see both varieties. So first we are going for the method 1. So let V is the voltage across this node. V is the voltage across the node. So apply KCL at node V. So across this node V, incoming currents are treated as negative and outgoing currents are taken as positive. So node V is connected to 3 branches and we know the currents in the 3 branches. Directly we are writing the KCL. So current in the first branch is incoming. So this is minus 5 of 0 degrees. And I1 is also incoming. So this is negative I1 of t. Next 10, this is current flowing through this branch is going outwards, so that is plus 10 of 60 degrees is equal to 0. So finally we can write it as I1 of t is equal to 10 of 60 degrees minus 5 of 0 degrees. And we know that one, this is simply, it is in the form of r into j theta. R into j theta, and j theta can be written as e power j theta is cos theta plus j sin theta. So here you can write it as 10 times of e power j theta, that is 60, j 60. So you can write it as cos 60 plus j sin 60 minus 5 times of cos 0 plus j sin 0. So this can be simplified as 10 times of cos 60 is 1 by 2 plus j root 3 by 2 minus 5 times of 1 plus j 0. So this will be equal to 10 by 2 is 5 plus j times of 10 root 3 by 2 minus 5. Minus 5 plus 5 get cancels. I of t is equal to, I of t you will get it as, I of t you can write it as I of t is equal to j times of 10 by 2 root 3. Okay, this j can be written as I of t is equal to 10 by 2 root 3 of plus 90 degrees. So the right option is A. A is the right option that you can get from the simple KCL. And now we can get the same thing with the help of superposition theorem also. So we are dealing with method 2 using superposition theorem. Using superposition theorem says superposition theorem can be applied if the network is consisting of more than one source and overall response of that network is equal to sum of individual responses. While calculating individual response, you must consider one source at a time and you must nullify all other sources. If the other sources are voltage sources, they must be short circuited. If the other sources are current sources, they must be open circuited. Okay, using this way you have to calculate individual responses. Later you have to add all those individual responses to get the overall response. That is what superposition theorem says. So this is source 1. Okay, say this is I5, that is current 5 amperes, and it is current 10 amperes, I10. We are going to calculate I1. Okay, so first total current I1 of t is equal to I1 of t when 5 amperes is applied and I1 of t when 10 amperes is applied separately. So we are going with individual responses. So what is the value of I1 when 5 amperes is applied? What is the value of I1 when 10 amperes is applied? So both are individual responses. Both will be get added to get the overall. So first we will calculate I1 of t when 5 amperes is applied. 5 amperes is applied is nothing but this is gets open circuited. Okay, the other source is current source is gets open circuit, that means no current is coming in this way. Current coming from this one is 0. So simply this is flowing in this direction. So I1 and this 5 amperes is same but flowing in the opposite direction. So you can write it as I1 of t is equal to minus 5 of 0 degrees. First equation. Similarly, I2 of t when 10 amperes is applied. What is the value? When 10 amperes is applied, 5 amperes current source is gets open circuited because only one source should be considered at a time, so that it will be acting as open circuit. When it is open circuit, at that time no current is flowing into this inductor. So current flowing through this one is 0. So simply 10 ampere source is going in this direction. So I1 of t and 10 amperes are going to be same, both are in the same direction. So this is I1 of t when 10 amperes is applied is equal to 10 of 60 degrees. Second equation. Now from this first equation, overall response is minus 5 of 0 degrees plus 10 of 60 degrees. So I1 of t can be written as 10 of 60 minus 5 of 0 degrees. So that is same as this one. So you are again coming into this point, and then you are going to get the value of I1 of t as using the previous procedure with 10 by 2 root 3 of 90 degrees. You can write as 5 root 3 of 90 degrees, but answer is given in terms of 10 by 2, so you are writing. So the right option for this question is A, 10 by 2 root 3 of 90 degrees plus. Thank you.